Last quarter, I was reviewing a project timeline with a client. Solid architecture, good platform choice, executive buy in. They asked us why the build phase was taking longer than scoped. The answer wasn't the complexity, it wasn't the data. It was that they'd been trying to hire a fabric data engineer for 4 months and hadn't filled the role. The project was sitting on three people doing the work of seven, and those three were burning out.
That story is not unusual. We're hearing a version of it in almost every enterprise engagement right now. The data and AI roadmaps have never been more ambitious. The budgets have never been larger in real terms. And the single biggest constraint on execution is not the technology, not the platform, not the architecture decisions we've been discussing all season. It's people, specifically the right people. And there aren't enough of them.
Demand for data engineers globally is outpacing supply by 3.2 to 1. There are 1.6 million open AI related roles worldwide and only 518,000 qualified candidates. This is not a pipeline problem that's about to resolve itself. It is getting worse, not better.
Welcome to Discovery to Solutions, where we bring technology conversations from the whiteboard to reality. I'm Kavya Malhotra.
And I'm Karan Khanna. We've touched on the talent dimension in almost every episode of this show. We mentioned Fabric Architect demand being up 180% year on year in episode 1. We talked about the data engineering role expanding by 10 times in episode 2. Today it gets its own episode because it deserves one. Because it's the quiet reason behind more project delays and budget overruns than any technical decision we've ever discussed.
This episode is for CDOs and CTOs whose projects are slipping and aren't quite sure why. For data teams stretched thin across 3 platforms doing the work that needs 6 people. And for anyone who's been told we'll staff this properly in Q3 for 3 consecutive quarters. Q3 is not coming.
Let's put some real structure around the problem. Data engineering is not a niche role in decline. 55% of data professionals today identify primarily as data engineers, up from 40% in 2021. Companies are now putting 60 to 70% of their total data budgets into engineering, integration, and pipelines. Not dashboards, not models. The money is going to data engineering. The roles are increasingly centered on data engineering, and the talent pool for data engineering is structurally unable to meet that demand.
And data engineering sits inside a larger tech talent crisis that's genuinely severe. The World Economic Forum's 2025 Future of Jobs report lists AI and big data as the single fastest growing skill area globally. 75% of businesses are reporting tech talent shortages. There are 2.9 million data related job vacancies worldwide. Those aren't projections. Those are open roles today that organizations cannot fill. And the technology landscape is not making it easier. 71% of technology leaders say skills shortages caused project delays in the past year. 49% had projects cancelled entirely. Not paused, cancelled.
And for Zility specifically. And for anyone building on Microsoft Fabric, the specific shortage is acute. We referenced this in episode 1. Fabric Architect demand is up 180% year on year. Fabric has been generally available for 2 years. The platform adoption has significantly outpaced the rate at which the industry has produced people who know how to build on it. Microsoft ships features fast. The talent market catches up slowly. And the gap between those two speeds is what every Fabric project is running into right now.
Now, the obvious question, why isn't the education system producing more data engineers? It's a fair question, and the honest answer has 2 parts.
Part 1. University curriculum moves slowly. What gets taught in a 4-year computer science degree reflects what the industry needed 4 years ago when the curriculum was designed, sometimes longer. The modern data engineering stack, Spark, DBT, cloud lakehouses, streaming architectures, vector databases, feature stores, data contracts, Most of this doesn't exist in any meaningful way in undergraduate programs right now. What universities produce in 2026 are graduates who know SQL, Python basics, maybe some Hadoop concepts from a professor who last worked in industry in 2019. Databricks, Fabric, Iceberg, Delta Lake, Airflow at scale, those get learned on the job, if the job has someone to teach them.
Part 2, the role of data engineer didn't really exist as a distinct job category until the mid 2000s. Before that, it was split across database administrators, ETL developers, BI developers, and backend engineers. The discipline is young, the specialization is newer still, and the rate of platform change from on prem warehousing to cloud data warehouses to lake houses to AI ready infrastructure means the skills that define the role have completely transformed multiple times within what is still a relatively short career arc. You can't produce 10 years of graduates in a role that's been clearly defined for 5.
And there's a newer dimension that's making this worse in real time. LLM engineering skills in data engineering job postings surged from 3% to 12% in a single quarter between late 2025 and early 2026. 45% of all data and analytics roles now explicitly mention AI expertise. The role is not just growing, it's transforming. Faster than any curriculum, any boot camp, any internal training program can realistically track. Every quarter, the job description changes, the talent pool that can actually fill it gets smaller. Now, let me be specific about something that gets talked around but rarely said plainly. There are a lot of people with data engineer or ETL developer on their CV right now who are not equipped to build on modern data platforms. And that's not a criticism. It's just the honest result of how fast the landscape changed.
What's the actual difference? Walk through it.
An ETL developer, classically, knows the extract transform load cycle. They can configure SSIS, Informatica, Talent, IBM data stage. They're excellent at moving data from source A to destination B according to a defined transformation logic. In a stable, on prem, structured environment, that skill set delivers real value. A modern data engineer needs to operate at a different level of scope. Cloud native pipeline architecture across AWS, Azure, or GCP. Distributed processing on Spark at petabyte scale. Streaming data with Kafka or similar. Orchestration with Airflow or Dagster. Data modeling in dbt for transformation and documentation. Medallion architecture implementation in a lakehouse. Data quality frameworks with great expectations or SODA. Governance integration with Unity Catalog or Purview. And increasingly, feature stores, vector databases, and pipeline support for ML model serving. Those are not adjacent skills that can be picked up in a weekend. That's a fundamentally different job.
And the painful reality for organizations that don't recognize this gap. They hire someone with 10 years of ETL experience on a legacy platform, put them in front of a Fabric or Databricks build, and then wonder why delivery is slow and the architecture decisions feel uncertain. It's not a performance problem, it's a fit problem. And it's one that a job description with the words data engineer on both sides doesn't reveal until the first architecture review 3 months into the project.
And upskilling existing ETL talent is not fast. It's possible, absolutely possible. But the realistic timeline to take someone from classic ETL work to competent modern data engineering is 12 to 18 months of focused learning alongside real project exposure. Most organizations don't have that kind of patient runway when they're mid project on a platform migration. And most individuals don't have that kind of structured support when they're expected to deliver while they're learning. So, what does this actually mean in practice for anyone trying to deliver a data or AI project right now? First, time to hire has lengthened dramatically. Filling a senior data engineering role now takes 66 days on average, according to current hiring benchmarks. For platform specific roles, Fabric architect, Databricks lead. We're regularly hearing of searches running 3 to 6 months without a successful placement. Every month that role sits unfilled is a month of delivery velocity your project doesn't have.
And when you do find the person, you pay for scarcity. AI related roles are commanding 67% higher salaries than traditional software positions. Fabric data engineers are averaging $129,000 a year in the US, and that figure is climbing 5 to 7% year on year. The salary expectations for platform specific talent have reset to a level that many mid market organizations budgeted for but didn't really internalize until the offers started coming back. And beyond the hiring cost, the most underpriced risk in most project budgets is the cost of the wrong hire or the underskilled hire. A data platform architecture decision made by someone who isn't fully current with the platform can create rework that costs multiples of what the role costs. We've walked into projects mid implementation, 6 months in, significant spend already committed, where foundational decisions had to be unwound because the team building it didn't have the platform specific depth the project needed. That rework is expensive, and it's time you don't get back.
All right, let's talk about what's actually working. Because there are organizations navigating this well, not by wishing the talent shortage away, but by building a model that doesn't depend on the shortage resolving. The first shift that's working is the hybrid model: permanent staff for core roles, specialist partners or contractors for platform specific build phases. You don't need a fabric architect on payroll permanently. You need one intensely for the 12 months you're building and stabilizing the platform. And then you need a team that can operate what was built. That's a different hiring and engagement model than find six permanent hires and start building. The organizations that have separated the build phase from the operate phase are moving faster and spending more sensibly than the ones trying to assemble a permanent team before they've even started.
The second shift, leaning on delivery partners who already carry the platform specific depth on their bench. If you're building on Fabric and your consulting partner doesn't have certified Fabric architects, that's not a Fabric problem. That's a partner selection problem. The organizations navigating this well chose their delivery partner not just on methodology or price, but on the actual bench of certified specialists who can be on the project within weeks, not months. The partner dimension matters enormously in a tight talent market. And it's one of the most underweighted factors in how most organizations evaluate and select consulting relationships.
Third, and this is the one with the longest payoff but the most durable outcome: structured upskilling. Not let's send 3 people to a boot camp. Structured, planned, supported investment in taking existing talent, people who already understand the organization's data, systems, and context, and building the modern platform skills on top. The organizations doing this well pair the upskilling with real project exposure, not training in isolation, training while building, with a more experienced engineer on the same project who can course correct in real time. That model produces retained, contextually deep engineers that no external hire can match. It just takes 12 to 18 months, which means starting that investment now, not when the next project kicks off.
And the fourth shift, and this one sounds small but isn't, rewriting the job descriptions. We've seen organizations post for a senior data engineer, expecting one candidate to be expert in Fabric, Databricks, Spark, DBT, Airflow, streaming, governance, and ML pipelines. That person does not exist in the volume you need them to. And if they do exist, they cost more than your job description is priced for. The organizations getting candidates through the door have decomposed those roles into what the project actually needs: a platform architect for the design phase, a pipeline engineer for the build phase, an analytics engineer for the transformation layer, instead of one mythical generalist who checks every box. All right, a CDO calls us. Their data platform project is 6 months behind. They blame the technology. What do we actually tell them?
First, Audit the team before you audit the architecture. Walk me through who's on the project, what their actual platform experience is, not what their CV says, but what they've built and shipped, and where the coverage gaps are. In more than half the cases where a project is running late, the architecture is fine. The talent composition isn't. And that's fixable, but only if you diagnose it honestly, not if you assume the problem is somewhere in the data pipeline.
Second, separate the talent budget from the infrastructure budget and make sure both are realistic. I've sat in planning sessions where the platform license and the cloud compute costs were budgeted to the dollar, and the talent line said two senior engineers market rate. Market rate for platform specific data engineering talent is not what market rate was 3 years ago. If your talent budget reflects 2022 salaries for a 2026 Fabric or Databricks build, you're not under resourced. You're mispriced. And mispriced budgets produce a very specific kind of delay.
Third, and I want to say this without it sounding like a pitch because it's just true based on what we've watched happen. The delivery partner you choose for a platform specific project is a talent decision as much as it's a methodology decision. If your partner doesn't have the certified practicing bench for the platform you're building on, you are inheriting the talent shortage, not circumventing it. That question belongs in the partner evaluation, not in the first architecture review 6 weeks after kickoff.
And the broader truth underneath all of this, data engineering talent is the infrastructure that every AI initiative, every real time pipeline, every governed data platform we've discussed on this show is actually built on. You can have the right architecture, the right platform, the right governance model, and still not deliver if the people who build it aren't on your team. Talent is not the soft side of a data strategy, it is the hard constraint. Plan for it accordingly.
So, the data engineer shortage, real, structural, growing. Not because there's a lack of people interested in the field, but because the field is transforming faster than the supply chain of people trained for it. The organizations adapting well are the ones that stopped waiting for the market to fix itself and started building delivery models that don't depend on that fix arriving.
Hybrid models, specialist partners, structured upskilling, and honest job descriptions. Not glamorous, not a keynote topic, but the operational difference between projects that ship and projects that sit in planning for another quarter.
If your data roadmap is ambitious and your talent plan is vague, that's the conversation worth having before the next kickoff, not during it. We've seen what happens when it happens during.
Next episode, we're turning to a question that keeps coming up in our platform conversations more often than it used to a year ago. Snowflake in 2026, still relevant or being replaced? Fabric and Databricks have taken a lot of the oxygen in enterprise data platform conversations. But Snowflake hasn't gone anywhere. And for a specific set of use cases, SQL first teams, multi cloud data sharing, organizations that genuinely don't want to manage infrastructure, the case is still compelling. We'll also talk about the migration patterns we're actually seeing and the cost conversation. Snowflake's consumption model versus Fabric's capacity model is one of the most misunderstood comparisons in the market right now.
See you in the next episode. Thanks for listening to us on Discovery to Solutions.